Good morning, dear students. I am Asha Pawar, working as Assistant Professor at SNJB's Let's Serve KBJ College of Engineering, Chandwad, Nasik. Student, today we start new unit in Engineering Chemistry syllabus, that is Instrumental Methods of Analysis. First of all, we study representation of cell because various cells used for the measurement of E cell, that is electromotive force or EMF of the cell. So we use the different types of cell in the form of anode and cathode. Then how to represent on the paper? For example, here I take a Daniel cell. Anodic half cell is written on a left side and cathodic half cell always written on right hand side. For example, zinc solid, that is electrode, zinc rod in presence of zinc sulfate, and copper sulfate solution in presence of copper electrode. So at the right side there is a cathode, that is this is a half cell, copper in copper sulfate, and at the left side zinc in zinc sulfate, it is a anode. So two half cell are represented by double vertical lines. Double vertical line indicates salt bridge or any type of porous partition. That is, these two half cell, zinc in zinc sulfate and copper in copper sulfate, can be separated by using the salt bridge. It indicated by the double vertical line. Electromotive force may be written on the right hand side of the cell always. Single vertical line indicate the phase separation between electrode and electrolytic solution. See here, zinc in presence of zinc 2 plus, that is zinc sulfate, and copper in presence of copper sulfate, that is copper 2 plus, indicated by the single vertical line. Invert electrodes are represented in the brackets. So for the measurement of the electromotive force, or we say it is E cell, we use this Nernst equation. E cell is equal to E0 cell minus RT upon NF into ln Q. So E cell means cell potential under the non-standard condition in volt. E0 cell means the standard potential or standard cell potential under the standard condition. R is a gas constant, T is a temperature, N means number of moles of electron exchange in the electrochemical reaction, that is oxidation and reduction takes place. Some potential is developed, means redox reactions happen, and how many number of involves, that is nothing but the N. F is a Faraday's constant, which is a constant value 96,500 coulombs per mole, and Q is a reaction coefficient, which is the equilibrium expression with initial concentration rather than equilibrium concentration. That is, we take the some electrolyte, that is either in the oxidized form or either in the reduced form, that is this is the reaction coefficient indicate that concentration of that electrolyte. So during the measurement of the electrode potential, we use the electrodes. Then what is exactly the electrode potential? Electrode potential nothing but an ability of that electrode either loss electrons or either gain electrons is known as electrode potential. Means if we use the two half cell and make a complete cell, then some redox reaction happen and either electrode loss electron or either electrode gain electron. That ability of that electrode either losing electron or either gain electron is nothing but the electrode potential. So depending upon the reaction happen, then there are two types of electrode potential, oxidation potential and reduction potential. The ability of electrode to lose electron when it acts as anode, means one of the half cell can act as an anode and it loss electron. That ability of that electrode or anode to lose electron is nothing but the oxidation potential. Second type of potential is reduction potential. The ability of electrode to gain electrons when it acts as a cathode. That is, if one of the half cell act as a cathode and it gain electron, that ability of electrode to gain electrons, it is nothing but the reduction potential. So for the measurement of electrode potential, we use the different types of electrode in electrochemistry. First one is a reference electrode, second one is the indicator electrode, and the third electrode included in your syllabus, that is the ion selective electrode. We study one by one. Then today we learn first cell, that is the reference electrode. There are two types of reference electrodes used in the electrochemistry generally. Primary reference electrode, most common example is hydrogen electrode. We say it is a standard hydrogen electrode, SHE. And the second one is a secondary reference electrode, most commonly used Calomel electrode, silver chloride electrode. Another example, mercury sulfate electrode, mercuric oxide electrode, glass electrode, quinhydron electrode, etc. So the reference electrode included in your syllabus for the diagram, its construction and representation, that is the Calomel electrode. So Calomel electrode is most commonly used secondary reference electrode. The principle of using the Calomel electrode, that is the potential of Calomel electrode is totally depend upon the concentration of potassium chloride solution used as electrolyte in Calomel electrode. If KCl solution is saturated, then its potential is standard 0.2451 volt, and such a electrode is called as saturated Calomel electrode. If KCl solution is 1 normal, then potential is 0.284 volt, and such electrode is known as NCE, normal Calomel electrode. And if KCl solution is used 0.1 normal, then its potential is 0.3338 volt, and such electrode is called as DC normal Calomel electrode. So its construction, such a glass tube can be used for making the Calomel electrode. At the bottom of that glass tube, pure mercury is filled. Then above to that mercury, there is a paste of mercurous chloride, Hg2Cl2. Then the paste of Hg and Hg2Cl2 is known as a calomel. That's why the name of electrode is Calomel electrode, and the remaining tube is filled with the electrolyte, that is KCl solution, and most commonly used concentration is saturated. This is the side arm tube. It may be act as a salt bridge. For the electrical contact, platinum wire can be used that directly dip in mercury. So the representation of Calomel electrode, it can be represented like that, that is Hg in contact with Hg2Cl2, and it is directly in contact with the electrolyte, that is KCl, and in bracket write the concentration of KCl used, either it is 1 normal, 0.1 normal or saturated. So if Calomel electrode is act as an anode, it mercury get oxidized, means twice Hg gives twice Hg plus 2 electron, and if Calomel electrode act as a cathode, then the reduction reaction, that is twice Hg plus twice Cl minus plus 2 electron gives Hg2Cl2. So overall reaction happen, that is twice Hg plus twice Cl minus gives Hg2Cl2. Thank you.